record on this computer. All right, here we go. So, any questions about what we covered yesterday? Pretty straightforward. I mean, especially if anybody's been through the curriculum, there was no new surprises there. Well, except maybe the fact that they removed the IPv6 version of OSPF. Kind of sad because I rather liked configuring OSPF v3. Today, as I said yesterday, I don't know if you picked up on this, Mike, but today we're covering chapters 3, 4, and 5, but 3 is cybersecurity, and it's really just an introduction to cybersecurity to give you some overview of what's going on. It's all informational. There's no labs that I'm going to have you do. There's one live equipment lab that I would encourage you all to go through if you've never done stuff with Wireshark. It's kind of cool, and it's basically observing DNS traffic. It gives you a little bit of an insight to Wireshark if you've never used it. If you've used it and you're an old hat at it, then it won't be at all exciting. So
is that similar to the labs that are in what was that, Introduction to Cybersecurity, and then there was Cybersecurity Essentials, I think. Because that one I did both of them, and that's why I did the cyber ops, so I could do both of those as like a precursor course for the kids.
Yeah, I be honest with you, I don't know if the lab is the same, but this chapter is, chapter 3 is kind of a summation of the highlights of what you might find in that either Introduction to Cybersecurity or Cybersecurity Essentials. I'm not sure which one.
Okay.
But it's just one chapter, right? They're really trying to get students, to think about security and possibly whet their whistle, whet their appetite, and have them possibly continue on and do the cyber curriculum. There's a lot of great courses. There's Introduction to Cybersecurity, there's Cybersecurity Essentials, and then of course the full cyber ops. There's IoT courses and connecting things, and then IoT security. I mean, there's 5 courses. That's 15 credits that you could put down as a major for, a networking degree or a network specialist or a security specialist. I mean, there's so many ways that you can go with this. Add the CCNA security. Now, I'm going to just pause for a second just to remind everybody, the CCNA security certification is gone. The CCNA security course is not, and they are actually updating it. So they're getting rid of the cert in the hopes that more people will go cyber ops. They've injected a bunch of stuff from the CCNA security into the CCNA, and I think we're going to see more when version 8 comes out. There's going to be a little bit more. I think eventually they are going to phase out CCNA security and bring some of the stuff into CCNA, and the rest of it will get pushed into cyber ops. So it's kind of what I see coming. I have no confirmation of that. No, Cisco's very, they keep everything close to the chest, so they don't tell us anything.
Hey, Mike, just so you know, the advanced security for Cisco is a CNSS certified 4011 class, I think it is. And that's a pretty standard certification for government. So I really don't see them getting rid of the class. They may revamp it, but a lot of government personnel kind of required to take that kind of level of information. If you look it up, it's CNSS, and this is a certification for the government employees.
So okay, so this is not a Cisco certification.
Well, it may not. It used to be. There used to be a Cisco certification associated with it, but this is also a class that government employees, government agencies send their employees to get that.
Yeah. So not knowing what this curriculum really entails, I would have to look it over. I'm not saying that they're getting rid of the content from the security class, the CCNA security. I'm saying they're going to redistribute it. That's my guess. They are revamping the CCNA security curriculum pretty soon, from what I understand. They're trying to get that done now, but there's a lot of projects going on. So I've already seen a lot of stuff come into the CCNA curriculum, and there's a bunch of stuff that's in that cyber ops. So I think they're just redistributing it to get rid of that certification class, because they've already ditched the certification. You can't get your CCNA security. I don't know about the CCNP security. I don't know if they have any plans for that. My guess is they'll probably keep that one around, because that's a much higher level than what we're going to do in CCNA. All right, so module 4 is ACL concepts. ACLs are access control lists. We put these on network devices. When we talk about a firewall, generally speaking, one component of a firewall would be access control lists. You know, there's different types of firewalls, and at the base level, as long as you have a fairly modern iOS running on your routers, you know, you'll have all the bells and whistles you need to run some full ACLs, preventing and allowing appropriate traffic, et cetera, et cetera. We really did get into ACLs much deeper in the security class. So that's, you know, an extra class you might consider taking down the road. So there's, you know, there's a general understanding, I believe, among all of us what ACLs are used for. But when we think about an ACL, we have to remember this is a list. In other words, there's many rules in this list, and Cisco calls these rules ACEs, access control entries. I prefer to call them rules. It's just an entry. It's a line item, if you will. And the way it works is every interface, remember, has two directions, inbound and outbound. You know, back in the day when we were still running different protocols, you know, some people were running IP traffic, some were running Apple Talk, some people maybe Novell, you know, whatever. The interfaces that could manage multiple protocols, you had an IP access list inbound on the interface potentially, and outbound, and they're different directions, so they have different meanings, they have different purpose. So you needed a different list potentially. It's possible to put the same list inbound and outbound. You know, coming up with examples of why you would do that is not, you know, a simple task. So offhand, I can't think of a reason. So you could have two ACLs per interface per protocol. So, you know, if you had a router with 3 interfaces, then, and you were running Apple Talk and IP, then there's 2 protocols times 3 interfaces times 2 directions. So that's 12 different access control lists in theory. So you could have 20 ACLs defined on your device, but only have, in this case, you know, in that example, 12 of them being applied. Now, there are other reasons or other ways that you could apply an ACL that's not direct to a interface. So if you're sitting there saying, no, wait, because you could put an ACL into a NAT configuration. Well, yes, that's true, but we're talking about in a firewall instance. So we'll just say that we can only have 12 of them as firewalls for interface, you know, kind of control. So well, we know today that we have IPv4 and we have IPv6. So there's two protocols for IP times the number of interfaces times two directions. So you could have 4 times the number of interfaces for ACLs. Basically, some of the things that an ACL can do, it can limit network traffic, right? So you can throttle traffic to preserve bandwidth, control the flow, what direction, traffic can head to, basic security. There's other things that you want to do. You can say no telnet traffic is allowed in or out of our public facing interface. All these other things, there's a ton, and this is just a short list. So in the ACL world, we're talking about filtering packets or filtering traffic. There's 2 types of ACLs currently. There's standard ACLs, and standard ACLs can filter traffic based on IP address only. And more specifically, based on source IP address only. An extended ACL can filter based on source and destination IP address, along with source and destination port addressing. So this is how we can filter out telnet. We need an extended ACL to say, no telnet allowed across this barrier. Or you can only telnet to this device, or this user can SSH to that device only. These are the kinds of things that we can build in. There are other types of ACLs that are really beyond the scope. I will mention them. We can do a date/time based ACLs. We can control traffic outside of business hours. Maybe you don't want anybody accessing certain resources after closing time just to be safe. A lot of things that we can do. So let's talk about the ACL operation. Remember, inbound is as traffic is approaching the router from outside the router. Outbound is traffic that has been switched from one interface to another by way of the routing process, and it's about to exit the router. So inbound and outbound. And when we're running full duplex, which hopefully nobody's running half duplex anymore, you have two directions on every single interface. So if this were gig 01 and this were gig 00, we would have an inbound to gig 01, and we would also have an outbound from gig 00. So 2 directions per interface. Basically, the way the process works, I'm going to actually explain all of this using this diagram. As traffic approaches the router, it hits the interface. The interface decides, hey, is this something I need to pay attention to? Is it destined for me? So it reads all the bits. It opens up the layer 2 frame, examines the MAC address. If the MAC address is that router interface MAC address, or a broadcast MAC address, or a multicast MAC address that this router is listening on, then the router will, hand that frame off up the stack, and it'll go up to layer 3, layer 4, layer 5, et cetera, et cetera. So the first thing it does is it comes in and says, hey, is this packet for me? If it is, the second step is, let me see if there's any ACL on the inbound side of this interface. If there is, it goes through the list of rules. Now, the way it checks is it starts at the top, and it checks rule number 1. Does this rule match enough that this packet can be either dropped or permitted? If it doesn't, it checks rule number 2, then rule number 3, 4, 5, 6, 7. It checks all the ACEs until it finds a matching ACE. Once it finds a matching ACE, it stops checking anything below that. And it applies the permit or the deny based on what the rule, so it applies the action that the rule defines. If it's a permit, then it hands it off to either, like a VTY line if we're dealing with Telnet SSH kind of things, or if it's a routing issue, it hands it off to the router to be routed. It does its routing check, and it pushes it across to some outbound interface, at which point we check for an outbound ACL on that outbound interface. If there is one, again, the same process. It checks through all the rules, applies the action of the matching rule once it gets to it, stops checking any further rules, and either permits or denies it. If it's a deny, it gets dropped in the bit bucket. If it's a permit, it gets handed off to the interface to be processed and sent out along its merry way. A lot of stuff to happen. When we think about security, you can believe that most routers are running at least some basic ACLs on them. So all of this stuff with all of these checks and balances in place, and the fact that we can get to Google and back in the blink of an eye is still just blows my mind. Okay. So when we looked yesterday at OSPF, we learned about the wildcard mask. The wildcard mask is often called an inverse mask. Basically, you take a subnet mask and you flip the bits. The ones turn to zeros and the zeros turn to ones. There's your wildcard mask. Another way you could do it is to take the subnet mask and subtract those decimal values from the global broadcast, all 255s, and you'll end up with your wildcard mask. So this is just a review. Some people teach ACLs before they teach OSPF. So these slides are kind of in both chapters because, you never know who's going to teach what first, more specifically in the previous curriculum. So I'm not going to go through this again today because I did that yesterday. If anybody wants a little bit more explanation, just speak up. I'm happy to do another example, but there's some examples here, and I think they're fairly straightforward. Here's the IP address. Here's the mask. So the permitted addresses are 192.168.1 dot anything, right? So here's a range. So you'll see that they can extend the range into a supernet here. So we have a summary or a supernet where the difference between a summary address and a supernet, and they don't really even use that term anymore. It's kind of funny. But a subnet, we take a network, a classical network address, and we make smaller groups out of it. So I could take the 192.168.16.0/24 and turn that into, a couple of /26s, a couple of /28s, and a few /30s. So I'm subnetting. I could take a summary address where I could take subnets and create a larger range that encompasses all of them. And that's really all a supernet is. The only difference between a supernet and a summary route is that a supernet goes left of the classful boundary. So in this case, it's the 16 network through the 31. And since this period, this dot, this third octet is the classful boundary for a class C, this is called a supernet. It's just a summary address, but they give it a name supernet. Okay. So in the ACL, here I am, I'm passing it along. They're actually showing you some ACLs. So here's access list. We give it a number, and we give it an action, and we give it an address, IP and mask value. So let me just back up. I got ahead of myself. So here, for example, this would permit everything in the 1.0 all the way to 1.255. Remember yesterday I mentioned if we take the network ID and a wildcard mask, we get the broadcast if we add them together. So that's a clear way to define the range. So access list, a number, and numbered access lists, right? 1 to 99 are standard access lists. So standard access lists only filter based on source IP. So it's an access list 10 is standard, permit is the action, and then I apply an IP address or a range somehow. Now I could specify a host address, right? If I wanted to, did they do that here? Yeah. So here's one way to add a host. Access list 10, permit 192.168.1.1. Just that address, because I've got nothing in the first, second, third, or fourth octet. So no additional addresses. Now I could just put access list 10, permit host 192.168.1.1 and leave off the mask. But that's the only keyword that we're going to use, either host before the host address, or you've got to supply the IP with mask values to define a range like this. Or, even a subnet or a supernet in this case, right? Here, I'm going to allow everything from the 16.0 all the way up to the 31.255 if I add these last two octets. That's how I get this. So calculating the wildcard mask, we did this yesterday. There's a couple different ways that you could do it, right? If I take the subnet mask for the network that I'm interested in and I subtract that from the global broadcast, I get 0, 0, 0, and 15. So that's the wildcard mask. One way to kind of the checks and balances with wildcard masks is you're never going to have an even number here, right? Except 0 if you consider 0 even. That's up for debate in the mathematics world. So these are always going to be an odd number. So if you get an even number, you know you made a mistake. So the any keyword is a way of saying like a quad 0. So we could use the host keyword when we have a quad 0 mask, or we use the any keyword when we're allowing everything. In other words, this is just a single host address in a wildcard. In standard subnet mask, this is how you represent everything. And this is everything in subnet mask. I'm sorry, this is one host in subnet mask and everything in wildcard. They're just backwards. So I could permit any. That's it. We don't need to apply a network ID and a mask. If we're going to apply the any, it's just access list 10 permit any. And the any keyword is very frequently used at the bottom when you create an access list. At the bottom of the list, there's an implicit access list, and then whatever number you used, deny any. In other words, if you're putting an access list together, it means you want to be safe and secure. So the rule by Cisco is, since you're trying to be secure, we're going to help you. You're going to put 1 or 2 or 3 rules in there, and we're going to automatically block everything else. If you haven't explicitly allowed it, it's not going to get through. You have to keep that in mind, because when you look at the access list on the router, you won't see that deny any. It's implicit. I teach my students that I think best practice is to put it in. If you put at the end of your access list, the last element or entry, if you put access list 10, deny any, now that one will show, and there'll still be an implicit deny any after it, but who cares? That's all. Now, if you're denying a bunch of traffic and then you say, I want to allow everything else, you'll have, access list 10, deny this, deny that, deny this, deny that. And then access list 10, permit any. And you'll still have the access list 10, deny any after that, but it will never it'll actually never get triggered because a permit any will let everything else go through and it won't get triggered. So, you know, I understand why they put it there. I just think it's kind of a waste. So I already talked about the number of access lists. So here's some best practices, right? Your organization should have a security policy that that talks to network security. If they don't, encourage them to create one, and then create your access lists based on the security recommendations from whatever committee decides to do it. I do a text document. When I create an access list, I'll type in a text document. I'll put in a comment, you know, a description of what I want the rule to do, and then I put the rule so that down the road, if you know, if I leave or somebody else comes and inspects this, they know what I'm attempting to do. They don't have to try to reverse engineer my logic and figure out what I was trying to do. So I do it in a text editor. Use a text editor to create, edit, and save all of your ACLs. If you only do one of these best practices, this is the one. Okay, you can edit an access list at command line. It's clunky, it's a pain in the ass, and it's just so much easier to do it in a text document, as I'll show you later on. Document using the remark. That's what I just mentioned. You can have an access list 10. You can do permit, you can do deny, or you can do remark. That's a comment, and the comment will show in the access list. So I put access list 10 remark, and then I'm trying to filter little Johnny here because he's been a naughty boy, whatever. Poor Johnny, he gets a bad rap all the time. Got to use somebody else's name like Philip or Josiah or something. Test the ACL on the development network before implementing them on a production network. Well, this is great for those of us that have Packet Tracer, right? You could build and test a whole bunch of scenarios, of course, unless you can't generate the type of traffic you're trying to prevent. If you just put ACLs out on the production network without any kind of real thorough testing, eventually you're going to find that you miss something, and it could be costly error. So standard versus extended. I already mentioned this. Standard, only filter based on source IP. Extended, filter based on source and destination IP, source and destination TCP or UDP ports, you know, the port numbers. And we can also filter a protocol type like IP, TCP, UDP, ICMP. So we can filter a whole group of traffic. Quite simple. So here we go. Numbered ACLs. 1 to 99 are standard. If I just do access list ? You'll see all the different numbers. No, I don't expect you to memorize all of these, but you certainly need to know these first two. 1 to 99, standard. 100 to 199, extended. Absolutely have to know that. Of course, ? will help you when you're going along and you're like, what was that range again? Was it 100 or did it start at 101? You know, whatever it is. They realized after all of this definitions that they wanted to allow for more access lists, because as ISPs grew and grew and grew, and we had more and more interfaces, you know, when we're talking about these stackable switches and we're putting ACLs on switches because maybe they're layer 3, maybe you're filtering on MAC addresses, whatever, and you know, you've got 1,000 ports, suddenly you find yourself saying, ooh, 100 ACLs, well, yeah, that's not enough. So they created these extended pools, right? 1,300 to 2,000 roughly is standard. It's another range for standard, and 2,000 to 2,700 roughly is extended ACLs. You can do 48-bit MAC address lists in the 11 to 1199 or the 7 to 799. So numbered ACLs, as soon as you type the number, the router knows, oh, standard, oh, extended. So it will change the options that it gives you when you use the question mark based on the number. But we can do named ACLs, IP, right? We have to start with IP access list, not just access list. Then we have to define what kind of access list it is. Is it standard? Is it extended? Because the word FTP filter doesn't tell the router whether it's standard or extended. So you have to specify. Now, an extended list, we get more options. And you'll see that here. Here, once we get into named access lists, we start with, right, we're in this NACL definition, named ACL sub configuration, if you will. Permit, deny, remark, permit, deny, remark, permit, deny, remark. We don't have to keep typing IP access list, extended FTP filter, blah, blah, blah. But we're going to permit TCP packets from the 10 network to any network as long as the protocol equals FTP. Well, those of you that are old hats at this, you know that there's 2 FTP ports. Those of you that are fairly new to this, FTP travels over port 20 and port 21. One of them is the data port, the actual file that's being transferred, and the other one is the control port where the communication, I'm ready, send me more, start the session, tear down the session, but not the data. So we've got to allow both to happen in order to allow FTP completely. Now, FTP is not very secure, right? Just like Telnet, everything travels clear text. So generally speaking, we don't allow FTP anymore or Telnet. What we do allow is SFTP or SCP in the Unix, Linux world, BSD world. SCP is secure copy. And what that does is it runs a CP, a copy command over an SSH tunnel. SFTP is secure FTP, and it's the same thing. It pushes the FTP protocol over an SSH tunnel. So as long as port 22 is allowed, right, I could replace this FTP with 22. Now, the thing is, there are some protocols that have words that you can type, but you can always type the port number that references that protocol. For example, if I type EQ www, that's going to allow HTTP, but not HTTPS. To get HTTPS, we have to enable port 443. So I just go with port numbers. I don't worry about words myself because, there's only some of them, and I don't like, again, it's a little bit of the OCD in me. I like things neat and organized. If my ACLs are going to reference ports and words, they're all going to be port numbers for me. I know the port numbers that I need to worry about, so it's okay. It's nice that they have these words so that you don't have to memorize port numbers, but you get used to it pretty quick. So, standard versus extended. If we had a communication going from PC1 and we wanted to say PC1 is not allowed to get to this side over here, right? Can't get to either of these networks. Standard ACL filters only on source IP address. So we're going to put we're going to put a standard ACL as close to the destination as we can. So I'm going to put it right here because, well, I don't want, this network to get to either of these networks. So I put it here and it blocks them from getting to either of the two networks. The downside to that is if we were only blocking one of these, I would also end up blocking the other. So if I just wanted to prevent LAN 10 LAN from getting to the 30 LAN, I would put it here outbound. If I were putting it here because I were blocking everything on this side, I would put it here inbound. Now, you could make an argument and say, well, why not put it here outbound, right? Since this is a serial link, router 2 might very well connect to the internet. So let's just say we could move it up here, because if we don't want them to get to either of these LANs, and this is the only thing they're going to do by crossing that link, great. But the reason we don't put it closer to the source, for example, let's just say I put it here on gig 000. Well, all I'm filtering on is source IP. So that means that when the packet comes in here, it says, oh, no, you're not allowed, which means I can't even go over to this network, or I can't cross this serial link. So standard ACL is close to the destination because we don't know where you're going. So we have to let the remote side handle that. Extended ACL, since we can filter based on your destination, we put them as close to the source as we can. In fact, if I were trying to say these guys are allowed to get to the server, but not this one, I would put that ACL with the rules in the correct order right here, inbound on gig 00 on R1. And what that does for me is it prevents these packets from wasting bandwidth only to get over there and get dropped and denied. So, we have to think about that. So extended close to the destination or source, standard closer to the destination. It's almost backwards of what you might think, but that's the simple way to configure them. Now, as we move forward in time, and as IPv4 gets phased out in favor of IPv6, you should know that there are no numbered ACLs in IPv6, and there are no standard ACLs in IPv6. Any standard ACL can be written as an extended ACL. So you have much better granularity, much better control, and we can ditch all of the standard ACLs altogether if you want. In IPv6, there are only named extended ACLs. Just simplifying things. Yeah. So standard ACL example. In the figure, the administrator wants to prevent traffic from the 10 network reaching the 30 network. I kind of anticipated this. So if we're going to do a standard ACL, if I were to put it here, that would be bad because it would also prevent them from getting to the 31. So I have to put that outbound on gig 00. That's all. Here's another example. R3, there are two possible interfaces on R3 to apply that standard. Oh, they're just going through all this. Sorry. A little bit different. Here's an extended example. If you want to deny Telnet and FTP to the 30 network from the 11 network, extended, we put it right here, right? Because I can say that you're coming from the 11 and you're trying to use port 20, 21, or 23 to get to the 30 network. The buck stops here. You could also put it here, but then it wastes resources on the LAN, or I'm sorry, on the router for routing that, right? If I put it here, I'm going to end up switching that packet/frame over to another interface only for it to get dropped. So this would be best practice. This would work, but it also is going to route something that is known to not be able to go. Just extended that. So that's just a basic understanding of ACLs. When I'm configuring an ACL, let's do this. So what I do is access list 10, remark, prevent the 10 net getting to 30 net. Access list 10, deny 192.168.10.0. Simple, right? Now, one of the things that you'll learn and through the lab, as we're building access lists and we're using our text editors, we're going to find that we might need to reorganize things a little bit, and it's a lot easier to do in a text editor. So what I do here is I do that. So now if I put the access list into the router and realize, no, something has to come before, like, let's just say I want to permit I want to allow the host 99, that's the IT guy, from getting to, I want to allow him to get to the 30 net. So, I typed all of this, I put it on the router, and I run some tests, and lo and behold, none of my hosts that I'm trying to block can access the 30 net. That's good. Now I go and I try the IT workstation, which is the 10.99, and bam, wait a minute, he can't get there either. Right? If we look at this, this is going to deny everything from 10.0 all the way to 10.255. Remember what I said? We go through the access lists, comparing every ACE. As soon as we find a match, we apply the permit or deny, and we bail. We stop checking. So this is very specific. These specific ones, right, they need to come before the more general. So think of it as a pyramid, the very, very precise, and then maybe a smaller subnet, and then the entire network. So what I do is I rearrange them. I copy and paste this into the router at the appropriate mode, right? Global config. What it does is it removes the old list and puts a new one in just like that. So in my ACL text files, I always have a no statement before I define the actual list, because then I can just paste the whole thing in one fell swoop. And here's the interesting thing. Once you apply an access list to an interface, if you delete the access list and then recreate it, it's still applied to the interface. You don't have to redo the command to apply it to an interface. This is how I manage, and this is how I teach people to manage their access lists. Always with a text editor. Always remove the access list right before you start defining it, so that we can just, Control A, Control C, Control V into the router, and bam, right? Everything happens in one swoop. So, guys ready to take 5? Go get a drink, go to the bathroom, whatever you do. So,
A quick question, Mike.
Yeah, who's?
So this is Bob. So
Bob.
is there can you use a flat file and load that into the router, or it is a copy paste kind of operation? I'm thinking of a
Yeah,
fat finger mistake or something like that.
it's a copy paste operation. You don't like upload an ACL file. It's not stored in it's not stored in a special file like the VLAN.dat file for VLANs. It's actually stored. These access list definitions actually get put into your startup config and running config. So you just have to copy it from the text editor and paste it into the terminal window. Okay. I'm just going to pause the recording for the break. Somebody help me remember to start it back up again in case I forget.
Mike, you're muted.
There we go. All right, so all I was saying is that tomorrow we're going to look at NAT, and NAT requires an ACL to define what traffic is allowed to go through the NAT engine. So tonight, there are 6 total labs. There's an ACL demonstration packet tracer activity, which it's one of those observation things. So there's no grade to it per se. And then there's 6 chapter 5 labs, configuring name, configuring numbered standard ACLs. And then there's 2 extended ACL scenarios. And then there's one where you actually modify, and they want to teach you how to modify ACLs from command line. Although I don't recommend it. I mean, do the lab so you know how to do it, but I don't recommend actually putting that out in progress. Now, it's possible that you're remoted into a router from somewhere else in the world, but that's okay. As long as you can open a text editor, you can still paste the ACL into your terminal window and it'll work. Remember, it has to be just a plain text editor. It cannot be like Google Docs. It can't be Microsoft Word, LibreOffice. It has to be just a plain text editor. I would recommend on Windows that you use Notepad++. If you're working on a Mac, you have to know that TextEdit, which is the built-in text editor, by default, it's set up as RTF. right? Rich text format, not text. So you have to go in and change that. Otherwise, you get all kinds of garbage being pasted. And if you're on Linux, there's dozens of text editors, free ones to use. So another one that I've started using on Linux, which I think is cross-platform, is Atom. Atom text editor is a great developer's text editor because you can, they say it's hackable. You can go in and customize it and add extensions. Like if you program a lot in Java or in a particular language, you can add extensions to make that programming a lot easier. You can do a lot of autocomplete. You can do things where you set up a template. So every time you start, like when I was teaching C++, I'd give them the template after we did it 3 or 4 times, and I'd show them how to configure it so they could just hit a key sequence and bam, the template's right there. They didn't have to open it or anything. It was embedded into it. This is kind of cool. Sublime text editor's another one. I've started using that a lot. I like it, but got to be plain old text editor. All right, so let's take a look at configurations, right? We're going to use a text editor. And, you know, if you get brave and you want to try to do this at the command line outside of, you know, doing it in the lab, obviously, I would refer you back to rule number 1, use a text editor. It's like, you know, the teacher's always right. 2 rules, right? The teacher's always right. If the teacher is wrong, refer back to rule number 1. The teacher's always right. That kind of thing. So here's the here's the syntax. Standard ACL starts with access list, then a number if we're creating a numbered ACL, then a permit, deny, or remark. If it's a remark, then put in your text and you're done. If it's a permit or deny, then you need a source IP and a source wildcard. And if you want to log the hits, then you log them. What it does, it's going to generate a message when that line gets matched, and then possibly send that to syslog, or you know, maybe the network admin has some kind of capture device that is capturing all these notifications. You know, who knows? But when it's matched, that's what the log will do. So if we want to create a named ACL, we have to start with IP access list standard, and then some name. Once we put that in, like IP access list standard, no access, you hit question mark and you'll see here are the subcommands. We can start with a sequence number if we're editing, because when you show the access lists, you'll see sequence numbers. Talk about that a little bit later. We can deny, permit, or remark, right? These are the 3 that we're likely going to start with. And then we have all of the extra stuff, right? The source IP, or the protocol, the source, the destination, and the protocol for the exit. Now, there's protocol, and then there's source, UDP, or TCP ports. So I could do, let's go back here. I could do an IP access list standard, no access, permit TCP from 192.168.1.1.0.0.0.0. So this is a host, equal whatever. I can actually put a source protocol that I'm using that goes, you know, within the TCP suite. The problem is with source ports, they're random, right? They're random. So a host generates traffic. He just reaches into a bag and grabs a free port number, and bam, he goes. So you can't predict it. However, return traffic has a predictable source port number. If I'm hitting a web server that's on port 80, the return source port is going to be port 80. So there, I can predict that. But we rarely put in a source port numbers. Always destination, because destinations are the server components running on a box that you're hitting. Port 80 is HTTP server, 443 is HTTPS, 22 is SSH, 23 is Telnet, 20 and 21 are FTP, you know, et cetera, et cetera, et cetera. So you know those. Okay, so once you define all of your ACEs and you've got the ACL ready to go, you go onto the interface and use the IP access group command, specify the number or the name, depending on how you configured it, and whether it's inbound or outbound. As soon as you apply it to the interface, every packet is going to start becoming inspected. Having it defined but not applied to an interface does absolutely nothing. Just keep that in mind. So here's an example. Access list 10 remark. Let's permit only the 10.10 to the internet. Here's the permit statement, permit host 10.10. Do show access lists, and this is what it looks like. Standard IP access list number 10 has this, line number 1. So those of you that remember programming in BASIC, we had line numbers, 10, 20, 30, 40. So access lists are very similar. They build them with sequence numbers that go up by tens. And that's so that you have a little room. So for example, hey, stop that. I could slip something in between 10 and 20 if I realized I forgot something that needs to go there by giving it a number in between, like 15 or 12 or 17, something in between 10 and 20. That's, you know, for a little bit more of a discussion later. So here's one that permits all hosts in LAN 2. So it's the 20 network and it's the 255. So it's all of the hosts in the 20 network. And this is what it looks like. Because I previously had an access list 10 and I added a rule to it, it still falls into the 10 net access list. You have to be careful with that because I'm going to apply this to a single interface in a single direction. And if the 10 and 20 network don't flow through the same interfaces, that could cause a problem. You'd be like, I don't get it. I've got the list. I'm looking at the rules. Why are they not happening? And trust me, you drive yourself bonkers for a long time. Now I'm going to apply this to the serial interface in the outbound direction as it leaves the router that contains both of these networks. IP access group 10 in the outbound direction. That's all there is to it. Show run, and the pipe allows us to start in the section for access lists. So we omit all of the other stuff. I just want to look at the section where the access lists are, and this is where they are. So I put in 2 remarks. Now, remarks, every time I add access list 10, blah, 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 access list 10, blah, 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 it keeps adding it to the end of the list, or almost the end of the list, because there's one statement that comes after all of these that I put in, and that's an access list 10 deny any. It's implicit, it's implied. Show IP interface serial 010, include access lists. Outgoing, we have an access list 10, and inbound, we have no access list set. I could look at the running config to see that as well, and look at the interface because I would see IP access list 10 outbound. Named ACL goes like this. Undo access list 10, create a new access list, it's standard, and we're going to name it permit access. And you'll notice that there's this pattern here. Every time we create a name, we tend to use capital letters. It's not a requirement. It just stands out more, and it's easier to see when you're scrolling through a text file with your config. Oh, there it is, there it is, there it is. Okay, yeah. So we can start with a remark. Hey, stop that. we start with this remark. We have a permit for the host. Then we put another remark, a LAN, IP access group permit access outbound, done. Now it's applied. You'll see here that the difference between configuring standard access lists, everything just happens at global config. Every line is a global config command. Named access lists go into an access list subconfig mode. In this case, because it's standard, it's std NACL versus ext NACL. So you know what mode you're in, and that's going to define what options you have, you know, when you hit the question mark. Standard named ACL or extended named ACL. Show the access list, its name, sequence numbers, what they can do. We can look at the access lists on the serial access list the same way. This is where, you know, the two rules come into play. Rule number 1, use a text editor. Rule number 2, if you decide not to use a text editor, refer back to rule number 1. But you can do it with sequence numbers. I'll show you how it looks. When we create an access list like this, we have 2 lines, we have 2 ACEs, so they're going to be a 10 and a 20. And sure enough, there they are. I can get rid of line 10. Maybe I fat fingered it and typed 193.168.10.10 or 19.168.10.10. Oops, fat finger. Get rid of 10 and re-enter number 10 correctly. So, yeah, if it's a simple little thing like a fat finger and you're not rearranging anything, sure, go ahead and do that. Honestly, I think it's faster to go into your text file, type the number, correct it, copy all, paste, done. Because remember, I'm going to have the no access list 10, and then the access list 10 with all the statements going to happen like that. That's just my personal preference. Modifying a named ACL, same thing, right? I can put a statement in by starting with a sequence number. When you show the access lists, it appears that it's at the top, but I think it actually injects it where it belongs in the list. And here's the other thing. If I reboot this router, these numbers will change. They'll become 10, 20, and 30. So let's just say, you know, what was I thinking? I put these 2 access list entries in, and I need to add 11 things in between, and I want to do it with sequence numbers because I don't believe the teacher. I'm going to do it from command line, not using no stinking text editor. If you put 9 things in and then reboot the router, those 9 things, instead of being 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, they'll be 10, 20, 30, 40, 50, 60, 70, 80, 90. So you'll have more room. Every time it reboots, it redoes the sequence numbers. Now, of course, you don't want to reboot a production router during, you know, production time. And, you know, maybe it's a business where you don't have any downtime. Maybe it's a 24/7 kind of thing. So again, just more reason, use a text editor. Just do it. Don't fight it. Don't try to see if you can do it the other way. Just trust me. You know, everybody always says, oh, I can do it. I'm going to do it. And after a while, they get very frustrated and said, all right, I'm going to use the damn text editor. It just is easier. You can look at the statistics, which show you how many times this ACL was matched and how many this was matched. So you might put one up there and you're testing it and it's not working and go in and see 0 matches, right? There's no matches. Why is this not catching it? I don't understand. maybe, oh, wait a minute. Of course, there's no matches. I forgot to apply it to the interface, or I put it on the wrong direction or the wrong interface. I mean, there's a lot of reasons why it doesn't work. Now, those of you that know the answer to this, who've been through the curriculum, that understand that securing VTY access is a little bit trickier. Well, it's not really trickier. It's just different. Don't respond. I really want to I want all of you to start thinking. VTY is used for remote access, right? So we can SSH to a router. We can telnet to the router, whatever it be. I want you to think about, how would you go about securing remote access? Because when we remotely access a device, router and or switch, that router could have 10 interfaces on it. And I can telnet, SSH, whatever, to any one of those 10 IP addresses. Now, a switch, just a standard access level switch, would have no IP addressing except the management interface. So we generally just SSH to that IP. Now, if it's a layer 3 switch and we're doing inter-VLAN routing, there could be 40 SVIs, and I could SSH to any one of them. So any thoughts on how to prevent or protect, I should say, remote access? At least be thinking about it, right? Because there's multiple interfaces, I don't know which interface you're going to be coming in on. So rather than have to put all the access lists to protect remote access on your other traffic filtering access lists, and then what happens when somebody adds another interface or lights up another interface and doesn't think to add the ACL to it, right? Now that's a problem. So we can actually create a simple access list. It could be standard access list, because generally remote access is only allowed by a few people, like your IT staff, and generally speaking, the machines they're using are on the management network already. So you could say, any device that's in the 99 VLAN, let's just say that that's your management network. Any device that's in the 192.168.99.0 and then 000.255. So we could permit those and then deny everybody else. But instead of putting it on individual interfaces, we apply it to the VTY lines themselves. So now any interface that gets lit up is protected, because we're actually protecting the VTY infrastructure. So we create the ACLs in exactly the same way. They're no different. But when going to apply it to the VTY lines, we go to line VTY 015 or whatever, access class instead of access group, and then the number or name of the list you just created. And then, of course, inbound or outbound. In other words, do we want to allow people to remotely access this device, or from this device remotely access another device? So generally speaking, it's all about inbound. We protect the other devices by having inbound access lists on them. So I have never in my life put one on the outbound interface for VTY. Always inbound. Not to say that you can't. So this is what it might look like. Create a username admin with a secret password of class, right? Create an access list that permits this guy, 10.10, he's the boss. Deny everybody else. Is this line really necessary? No. But now it will show when I do a command like show access lists. The other way, if I didn't put this deny any, then it doesn't show up when you show access lists because it's implicit. I like this. This is, in my opinion, this is best practice. Good stuff. Then go on to the VTY line. Specify login local, right? So only username admin with a password of class is going to work. Transport input telnet or transport input SSH, whatever we're doing. Access class, admin host was the name, inbound. Now, only somebody sitting at the 10.10 can remotely access the VTY infrastructure on this router. No remote access for anybody else. Of course, if the admin gets up and goes to the bathroom and leaves his computer open and somebody jumps on it, right, it's coming from 10.10, so now we have this backup. What's the username and password? And hopefully they have strong passwords and so forth. So it's, it's like two-factor authentication, if you will. Looking at the ACL statistics on the access list, the device where the access list is, you're going to get a log message. And then if I do a show access list, you'll see how many matches came from this and how many matches were denied. If you see a lot of these matches being denied, then there are people trying to get into your device. So just kind of alerts you. Of course, SSH would be better than Telnet. Configuring extended ACLs. Let's look at the syntax for them. Numbered, obviously, those are 100 to 199. And then with named, we have to start with IP access list extended and then give it a name. The differences here, there's no IP for numbered. There is IP for named. We don't specify extended because the number does that for us, versus here we have to specify extended because the name doesn't imply anything. What does foo mean? Standard or extended? It's just, there's no way to do that. Okay, so access list 100, permit, and then all these other things. There's more stuff in the extended than there is in the standard. We're going to focus mostly on ICMP, IP, TCP, and UDP. There are other things here that we can filter, like we can filter EIGRP packets. We can filter OSPF packets. We can filter GRE tunnel packets, which you'll learn about. I don't exactly remember if it's tomorrow or next week. But typically the ones in orange, those are the four that we are typically working with. Once we put in a permit TCP, any EQ shows us all of the possible words. Www. It's just HTTP port 80. There's nothing here for port 443. Oh, don't forget to filter Gopher traffic. I'm not sure how many of you remember Gopher, but there were two of them back in the day for searching databases, Gopher and Archie. And I remember using those when I was in college. Finger, Echo, BGP packets. So they show you all the numbers. There's a lot of stuff here. Packet Tracer won't show you all of these. And what you can filter, this list will be dependent on the iOS and the version that you're using, right? Because it may not support certain features, but it's cool. So here's the big ones. Domain, right? DNS is 53. FTP, POP3, yeah, it's still used by a few. SMTP, Telnet, SSH is port 22, but these are not, like SSH doesn't have a number. I can't or a name. I can't type SSH. So anything that's not in this list is required to use the port number. That's it. So 443 for HTTPS, 22 for SSH. There should be a list in here of all the most popular ones. So access list 100 allow anybody for TCP from anywhere to any destination using www, or we can put 80, either one. They're identical. Permit 22, permit 443. This is HTTPS. 22 is SSH. In this case, what they're demonstrating is here, when you have a web server running, it's not uncommon to be listening on port 80 and on 443. So I actually have to create 2 separate entries, one for each of them. Just keep that in mind. The established keyword is common. We create a very tight firewall and we let traffic go out, and we don't necessarily want to have to create an ACL specific to that traffic, because after all, we don't necessarily know who's going to go out using what protocol. So we allow any traffic back in, and then we add the established keyword, because what that implies is that the traffic originated from within. Let's let the return traffic back, because you could end up allowing somebody to make a request, but you end up blocking the request coming back in. So established allows us to kind of say, any traffic that started here that went out, we're going to let you back in. There are other ways to do that, but they're beyond scope. That's in the CCNA security. So in this one, we're going to permit returning web traffic. So access list 120, permit TCP from anywhere going to the 10 network, as long as it was established. I don't have to specify web traffic. It's just anything. Maybe it's telnet, maybe it's web, maybe it's FTP. We're allowing that back in. So here's the permit the 10 network to go to any address for web services, and then allow any traffic coming back to the 10 network as long as it originated from inside. It's just a simpler way than trying to put this into reverse and have the source port be www and the source port be 443, and it's just simpler. The named, we did this, we covered this, so no FTP access. We can create names. Of course, your name should be somewhat descriptive. You know, a name of Foo Bunny Bear doesn't tell me anything, but a name of surfing or browsing kind of gives me an idea of what this ACL might be about, because at some point you have you have a lot of ACLs, and you want to be able to figure out which one that is likely in use, or which one to put the new rule in. Now, this term surfing or browsing, they are different, believe it or not. Just like internet, everybody says, yeah, just go to the internet and get it. When people say that, they kind of really mean the World Wide Web, don't they? Because you're going to open a web browser. There are protocols that get used on the internet that you cannot use through a web browser. Of course, that list is shrinking, as many of you know. Like IRC, for example. You used to have an IRC client. Well, now we can run IRC over port 80 and use a web browser. So the web is one part of the internet. And I think today's generation is going to have a hard time really grasping that, because, well, they open a web browser all the time. But, we stream Netflix. That's coming from the internet, not the web. We do IRC. I teach my students about IRC because I promote Linux. I make my students learn it, and I say, you know, for help, you can go use these IRC channels and get some assistance. You know, we talk about other protocols that are used on the internet that are different than the web, and I make that distinction. So here we have surfing and browsing, and to me, they're similar, but they do have different meanings, and they're using them to identify. Surfing is all the people inside going out to the internet, and they're calling browsing the return traffic. I don't know. That's a little confusing to me, but maybe not to others. And this is what it looks like. Allow 80 and 443 out, and then allow all the return traffic back in. So on gig 00, maybe that's connected to my ISP. I can put the surfing, or no, that's connected to my LAN. I put the surfing on the inbound before I hit the router, and then all of this return traffic is on the same interface, but outbound coming back into the LAN. This is an example of, we have two ACLs because we have one interface running in two different directions. That's all. So they're showing you can have two ACLs on one interface for each protocol you're running, IPv4, IPv6. And if you're, you know, that guy in your grandmother's basement running Apple Talk just because you don't want to see it die, well, then there's a third protocol, or Novell, there's a fourth one. Oh, let's get Token Ring fired back up. I actually have a Token Ring switch in my basement in a box somewhere. It came with a bundle of equipment I bought online when I was studying for the CCNA exam years and years and years ago. So each protocol could have two access lists per interface. IPv4, IPv6 are really the only two we're ever going to see these days. Show access lists. If there's extended IP access lists, they'll say extended. If they're standard, they'll say standard. So browsing and surfing are two different lists. Notice neither one of them shows deny any. Right? In standard, we only have source. So it's access list 10, deny any. In extended, it would be access list 100, deny IP any. So deny all traffic that's coming in over an IP network, or deny all TCP traffic, or deny all UDP traffic. Generally, the deny any is IP. It's the whole IP suite. TCP is a subset. UDP is a subset. So to capture them, we use the IP. So we can remove by sequence number the same way. Nothing new there. Another example, permitting a PC. Where do you put it? This is what it looks like. Permit PC1 TCP access to the internet. So I want to allow you to use 20, 21, 22, 23, 53, 80, and 443. FTP are the first two, SSH, Telnet, DNS, HTTP, HTTPS, and deny everything else. And then the return traffic. That's it. It's just how to interpret the example. Verification, you'll see them applied on the interfaces. Show run will show you the access list in the running config. Show access lists, there's all kinds of commands here, right? Here it is, show access lists. We can look at the running config. And that is extended ACLs and standard ACLs. Remember, you can configure absolutely any standard ACL using an extended. So there's really no reason to have the standard ACL. Any questions? Let me log into Netacad real quick.
Mike, just a general question. Companies don't use routers for their main security
Right.
appliance, if you will, right? And so,
In many cases, that is correct.
yeah. So what would you use? How many ACLs in general do you think they put on routers versus some other firewall appliance?
Well, yeah, and when we say routers, you have to realize what I'm talking about is a routing device.
Yeah.
So a common appliance once upon a time used to be a PIX firewall, which really was a very specialized router. It didn't do a lot of the standard router stuff. It was really geared more towards applying all of its resources to firewall stuff, packet inspection and so forth. Nowadays, you're seeing ASAs being used quite frequently, an adaptive security appliance. You have email appliances, you have web appliances, but all of these things have a routing process in them that allows them to do this packet inspection. Because anytime you have multiple interfaces, you have to be able to switch between the interfaces. And those interfaces are generally speaking going to be layer 3 interfaces, not layer 2. So a layer 3 switch, no problem. But think of it when it's that kind of a device. Yes, it's a switch. But if you're relying on the layer 3 routing functionality, it's also a router, right? It just looks different than your standard router. So I hope that clears.
Yeah, it does. Thank you.
Good. So in the CCNA security class, we work with the 5505 and 5506 ASAs for configuring. And the interesting thing is Cisco did not create the 5500 series ASA or whatever the first version was. They bought out a company that was building them. And the iOS that's on them is very similar to what Cisco had going, but there's differences. And some of the syntax is different. Show IP interface brief is a command that we use all the time on a router. But on an ASA, it's show interface IP brief. And you've got to know these little quirks because the iOS is not Cisco's. And I've often wondered, why don't they just rewrite it so that all of the commands stay the same and the terminology? Creating default static routes is very different. Setting up NAT is very different, but that's partially because of the way firewalls are configured. So it's a great class to take. It's really good curriculum because it really gives you some insight into securing your networks. If all you've been teaching is CCNA and that's really where your expertise lies, I encourage you, if you can find a local community college, or if your college teaches CCNP or something, or if you're an adjunct at a community college teaching CCNA and they offer CCNP or the security, you can usually take those classes for free. So take them. I mean, in my third year of teaching, I signed up at a local community college. I wasn't working for them, but I audited the CCNP classes, so it was a little cheaper, and I took them just because I wanted to, deepen my knowledge. So if we look at, where is the schedule here? Here we go. If we look at today, I've got a couple of labs. I've got 3 of the Chapter 5 labs out of the 6 listed here. 4.12 would be good to do. It's extended. It's scenario 1. 4.13 is scenario 2. You only have to hand in the ones in blue. There are 2 others. It's up to you. It doesn't really matter, I guess. Just know that you have to hand in the blue. Any others that are on the list, because all of the labs are listed here, right? There's 1, 2, 3, 4, 5, 6 packet tracer Chapter 5 labs. There's 1 live equipment lab. If you have your own live equipment and you can run this on live equipment, great. go ahead. I thought what would be good is, you know, I'm gonna bring up the chapter 4 lab, and I'll run through it here since we have the time, and that way you guys don't have to do it individually. So let's see, where's my packet tracer? There you are. Let me open this up. There we go. So topology looks like this. Remember, orange lights, spanning tree protocol. That's our time. As I said, this is just an exploratory lab. It's for observation. There are no assessment items, so they hide the assessment percentage, right? Because if there are no assessment items, it shows the percentage complete as 100, which really is incorrect, right? It should be an error because 0 points out of 0 is undefined. So they just don't show it. All right. So here we go. We have some lands. Oh, I hate it when they don't let me move those things around. They have some lands, the 10, the 11, the 30, and the 31 network. We had the server. This is the topology they used for some of their examples. In this activity, they want us to observe how the ACL can be used to prevent a ping from reaching hosts on remote networks, right? After removing an ACL from the configuration, the pings will be successful. Here's the addressing table, ping devices. So from the command prompt on PC1, ping PC2. So if I open PC1 and I go to the command prompt, I want to ping 10.11. Right, because that's in the same LAN. Now, I really can't prevent, little white lie, I can't really prevent PC1 from pinging PC2, can I? Because this is a layer 2 switch, right? So it's an access layer switch. It's not going to do me any good. And putting an ACL up here doesn't help me because, well, this traffic doesn't even need to go to the router. There are ways to make that happen, though, beyond scope at this point. Ping PC3. Well, PC3 is 11.10. Where's the options? There you are. This drives me nuts if that doesn't stay. All right. So ping 192.168.11.10. The first one timed out, not because of an ACL, but because of ARP, right? That address resolution had to take place. There, you know, it had to go out, the broadcast, and in the 2-second time, it didn't hear back. So the first one failed, the second one, third one, fourth one passed. If I hit it again, all of them will pass. So yes, all pings were successful. Ping devices on remote. So from PC1, ping the PC4 and ping DNS server. So we're talking about 30.12 and 31.12. So 30.12. Oh, look at that. We're not getting failures. We're getting ICMP message back that says destination host unreachable. But this is coming from 10.1. Huh, look at that. And same thing with 31.12. Right? So we can't ping remote networks. We can ping the local stuff, but nothing remote. Now, why did the pings fail? We're getting messages from 10.1. So they want us to go to simulation mode, and this is great. I always like when the students do this. Right, so go to simulation mode. I'm going to edit the filters, and I'm just going to look for ICMP messages, because the ping, the echo request, and the echo reply, along with the destination host unreachable, these all fall under ICMP. So I'm going to see any ICMP messages. On this, I'm going to reset it. That's interesting. Why are you there? I haven't asked you to do anything. This is all for the ping, the local one, so that's kind of crazy. So I'm going to reset this simulation. Come on. I want to clear the events. Where's the ability to clear the events? I'm going to do a ping 192.168.30.12. This is odd. Something's wacky here. It's putting my previous pings as yeah, come on, get out of my way. There we go. There we go. All right, so now I just have that one ping. It puts one ICMP message. I'm going to move this out of the view because I'm just going to step through this. So the ping generated, right? It's on the outbound interface of the fast Ethernet port on PC1. Here's the MAC address, source destination, right? The destination MAC address is going to be the MAC address of my gateway. Source MAC address, destination MAC address aren't going to change. This is an ICMP message of type 8. 8 is echo request. The echo reply is a different type, which we'll see when we get there. Reaches a switch, maybe ARP has to take place. The router receives this, right? And then puts a source is 10.1 and the destination is 10.10. So it's router 1 that's filtering this traffic, right? It could have gone all the way over here and been blocked. So on this one, that's the return. So if I open this, oh, come on. If I open it, I see that, you know, we've got inbound and outbound. So if we go to, we can look through, you guys have seen all of this, I hope. You've seen simulation mode. You know, they kind of give you a description. You can also look at the PDU, like they show them the headers in the curriculum as like a, you know, like the blocky spreadsheety looking things. And then over here, the final inbound layer and where it came. So they just want you to go through and look at stuff. So if we go to the R1 CLI and do a show access lists, enable show access lists. There's a standard access list which denies 10.10 or 10.0, the whole network. So this guy is being blocked from getting over here. But what about PC3? Right? Comes up, goes across and over just fine, right? The first one may have failed. These are failing now because I have two packets on the list. But that one passed because we only have one ACL for the 10 network. Where's my router? There you go. So I only have one ACL, and it's filtering the 10 network. Now, I don't know where it's being applied. So if I do show interface gig 0, I'm hoping that's this interface, right? Nope. Figures. If I look at the interface, let's see if there's anything here for us. MTU encapsulation, flow control, ARP. Nope, nothing here. Show run. Down here at the bottom, we have the definition of the ACL, and it will not show the deny any, which comes after the permit any. And then up here on gig, oh, it's on serial. That's where it is. It's on the outbound side. Serial 000 is saying outbound. So in all honesty, oh, this is standard. Sorry, I misspoke. If we were to put that on this interface, it wouldn't allow this guy over here from getting to PC3. So we're going to look at stuff. They want us to possibly alter it. So the first line originated in the 10, generates a message, right? So that because this router is filtering, it's going to generate a return destination host unreachable. That's an ICMP message. So then look at the show IP interface. That's what I didn't do there, IP. Show run include interfaces, shows you anything IP access list related. Remove access list from the configuration. I can remove it by removing the access list, but it will still remain. So if I do conf t no access list 11, do show run, you see it's still applied. So we also have to go to int serial 00 0 no IP access list or access loose access group 11. Ouch. Now it's completely removed. So just a nice simple little thing. And I expect that most of you have a pretty rudimentary at minimum understanding of ACLs and how they work. But you know, your students won't. And this will be a big deal to some kids, you know, whether they're high school kids. Anybody in here high school teacher? I should have asked that.
Yes.
Yeah. Okay. So
Yeah, Mike, I am too.
okay, good. So we got some high school teachers, and you know, sometimes high school kids are afraid to show that things are cool because their peers might not think they're cool, and then they'll be looked at as weirdos. And you know, so when they do these labs at home or on their own, and you know, you'll see them, they'll be like, yes, oh, that's cool, you know, whereas they might not do that around their other friends. If it seems trivial to you, don't assume it's trivial to them. Router 1, where are you? There you are. All right. So simple little lab, quick. You know, I like to have my students do these. I tell them to do them in class, and then we talk about them usually after. In a career tech, I'm very fortunate. I have students for 2.5 hours every single day, which is actually a double-edged sword. It's good and it's bad because I get they can do lots of good work in that time, but the state of New York says, okay, so you're teaching them Cisco CCNA. What else are you teaching them since they're there for so long? So we have to do other stuff. I teach programming, web development, things of that nature, sort of as side classes, but the focus is always this. All right, questions on anything? Are you guys okay with just reading through chapter 3 on your own? Is there anybody that's really dying to have me do the slide presentation? All 91 slides? Is there anybody out there that's saying, no, let's just get out of here because we're early and we get more time to ourselves?
Why is everyone laughing at 91 slides?
It's obnoxious. That's why.
Ah,
The CCNA security class, when they released the last version of it, the average number of slides per chapter was like 120. It's like, what the heck are you going to do with 120 slides? I mean, my God, I don't like to recreate things from scratch. So I take their slide decks and I modify them. I remove slides, and over time okay, I don't need that one. I don't need that one. Maybe next year I don't need that one. I find ways of minimizing it and having a more broader conversation about things, and then going through the slide deck. Yeah, talked about that. I just feel like we're being PowerPointed to death, and I'm sure that many of you feel the same way. But in a real,
Hey, Mike,
who's
if I
this?
have over 50 slides, I lose the high school kids on that. So
Oh yeah,
nothing more than that. Forget it.
when
of
you
course.
have too many slides, you lose them. And when you have too many slides, they just think, okay, we don't need to listen to you and your logic. And they just depend on the slides, or they start doing other things.
Right.
So you lose your entire class.
Exactly. So for my college classes, I tend to get rid of a lot of the slides and just keep the major points. I provide them the full unedited versions of the slide decks as well. So if they want to use those for studying purposes. But I mean, let's face it, in the security class, when you've got an average of 120 or so slides, some are 150, 160, it takes longer to read the slide deck than it does to read the chapter. I mean,
Yes.
that's just absurd. For my high school students, I don't do a whole chapter at once. I do the sections, and I was really happy when they started making the people developing these create section dividers. So I'll do section 1. Maybe it's 10 or 15 or 20 slides. It's manageable. And then there's a lab, and then there's, some discussion and so forth. So I will not do the whole thing all at once. I go through it, over a span of days. In a college class, that's a little bit harder. So what I tend to do with my college students is I have a discussion at the very beginning, try to keep it under 30 minutes about what we're about to learn. And then I go through the slide deck rather quickly, stopping on the really, really important stuff, emphasizing it, diagrams, configuration commands, and I'll stay there and have a little bit more lengthy discussion. But yeah, you're right. I mean, it's getting a little bit crazy, and that's why it's up to us to modify them. Modify them to suit your needs. That's all. So that's how I do it. Everybody does it differently, and it's great to hear you guys sharing this stuff because, I learn from you guys sometimes just as much as you learn from me. I do want to just briefly have a quick discussion about August 3rd, Monday. We can do a couple different things. We can just leave it open as a catch-up day and then start lecturing again on Tuesday and finish up on Wednesday. And I can do some non-curriculum training, if you will. I'm happy to do. I know some of you that were in last week saw stuff on Activity Wizard, so I could do some packet tracer things here. We could teach let's see, Glenn and Ethan and Bob, you guys all saw the packet tracer stuff, but the rest of you, I don't know if you know much about Activity Wizard. I don't know if you've ever used multi-user. I don't know if you've ever seen a packet tracer game. I'm happy to do that kind of stuff on Monday. So it's a no stress meeting. As another alternative, we could just move everything up a day, finish a day early, or like, the three of you, if we end up doing packet tracer things, if the three of you that were in my class last week are like, yeah, I saw it, I remember it, I internalize it, I don't need it, it's up to you whether you show up. So what is the consensus? I want you to be thinking about that. And if you have an opinion now, by all means, please share it.
Yeah, my opinion would be that I thought it was useful last week, and I think it'd be useful for those people who have not seen it to see it. And I would sit in again just to watch it, but I could also be doing some labs while you're doing that as well.
Sure.
I'd agree that it wouldn't hurt to see it again.
Okay. Those of you that were not in my class last week, just to get a sense, have any of you ever created your own packet tracer activity?
A couple of them, just to show different workings of different, what should I say? To understand different things in putting them together in class so the students can follow me, or have each of them design their own networks. Then I go around and look at it and have people come over and we look at the logic of different students.
Okay, so when I say activity, I mean something very specific, a PKA. I don't mean just opening packet tracer, build a topology, and make it all work.
Oh.
Have you a self-grading activity?
No.
Okay. Kevin or Mike or Valerie, have you ever?
The only thing Mike, the only thing I've done is I've set up unconfigured devices on packet tracer, and I've done labs like that, but not self-grading.
Yeah.
Yes, just like what he just said. Yeah.
Okay.
Yeah.
So that's what I'm talking about. I will teach you how to create your own self-graded activities, because it's a pain in the neck to have to open it, go look at the running config, or look at the output and, check the pings and show me the IP route. And it's so much nicer to just build it and then say, here, do it. It takes a lot of time up front to build the activity, but when you think about how much time you're going to save grading it down the road, immeasurable, not even close. Like, you will save so much more time than you can imagine. So, all right. So if you guys don't mind, then I'll do some more of that, and it'll just be very relaxed. There's no real curriculum here. I'm just demonstrating. And also, I think the multi-user stuff. Have any of you ever used multi-user environment in packet tracer?
2 years ago, Mike, you showed me that.
Okay.
We tinkered with like 3 LANs connecting in, like you. We would have a couple guys working on it.
Okay. Kevin or Valerie? No. Okay. So it's really cool because, the younger students especially, they love new and shiny and sparkly stuff. But even the college students, when I do multi-user in my college class, they're all like, wow, this is really cool. Like, I didn't think that this could do that. And it's so that I'll do the similar thing that I did last week. That'll be good. So the 3 of you that saw it, you can either participate with it. You can just listen in and work on labs, or, if you're not here on Monday and you're just working on getting caught up and getting your work done, that's fine as well. It's a no stress Monday. It's just teaching extra stuff because, we go through curriculum and it's like, you know, you're just cramming all this stuff in. It's nice to have stuff that goes beyond the curriculum. I used to do lessons, you know, teaching people how to set up their own classes. I don't think we have really too many brand new. I mean, I know, Ethan, you've never really set up a NetAcad course, but you certainly have played with Canvas. Oh, you did set up one. So, you know, there's things about setting it up is easy, but then going in and customizing and how do I do all this other stuff. But honestly, I don't really feel at this point it's worth doing that, because Cisco is ramping up to change LMSs. At the end of this month, they're opening the new LMS with the new courses. And it's not something you need to worry about. You're still going to go to NetAcad. You're still going to open the course. And it's going to take you automatically when you launch it. It's going to push you over to the new learning management system. But the creation is also going to happen from this same location. And they're trying to make it as seamless for the users as they can. But you will notice the layout and everything will be quite different. So, you know, we're going to be gearing up to probably do a presentation, teaching people, but we can't do the presentation because we don't have access to the development server. So we have to wait until the courses are out, and then we'll probably do some teaching. It's only for exploratory. It does not include any of the heavy hitters, the CCNA, the CCNP, the security, and I believe it also doesn't include the IoT stuff. It's all courses that are just exploratory. The intro to cybersecurity, the intro maybe to IoT, those kinds of things. But you know, you guys are smart. You'll be able to muddle through it and figure a few things out on your own. But having some training is nice. So.
Or Moodle through it, as the case may be.
Yeah, we'll Moodle through it. Not that I'm suggesting that it's a Moodle server, because Cisco will neither confirm nor deny that fact. I'm just kidding. It was funny in the beta. A couple people tried to pin them down to get them to outwardly say, yes, this is Moodle, and they just wouldn't do it. They would not say. They say it's an open source learning management system that we are customizing to suit the best needs of our clientele. Like, come on, what's wrong? Just say it's Moodle, because it's Moodle. That's what it is. It is Moodle. I run a Moodle server. I know what Moodle looks like, and this is Moodle. No big deal. Right? So, all right.
I had a couple questions related to the conversion. I guess it's Friday.
Yeah, and I'm probably not going to be able to answer them, but I will do my best if I can.
Do we have class on
Well,
Friday?
is there anything special that we need to do? I mean, I don't use a lot of the tests because the way we break up our semesters, I like use a little part here, a little part there and such. That's going to change with the new 7 curriculum, but so I went and exported my grades that I thought I needed and things like that, because it sounds like once it gets archived, it's really not going to be easy to get. Is there anything else I need that, that you're aware of that I should be doing with some of my old courses?
If a course is concluded, the bottom line is just export everything that you can out of it. I mean, export the whole course if you need to. Right? I export every course when it's over. So, they're going to archive it, but I still have a zip file with everything in it that I can, at some point, probably push back up into a course, even if I just use like a free Canvas account. It's tough because, like I'm thinking, well, what do I need all that stuff for? I have my grades, and I have all the labs that they submitted. I'm never going to be able to get back to their exams and see what they've done. So, yeah, I don't really know the answer to that.
Yeah. Okay. I mean, I've only been, using the Canvas for about 3.5, 4 years here. So my first couple of years was just kind of dabbling with it, but it's, this year I actually had grades in there, so I exported them out, and I'm still in the process of putting the content, because a lot of the stuff that I did, the prior years was all version 6. And I've downloaded all of the, the documentation and all that stuff for it. But
Sure.
I was reading through it last night, and I'm like, what do I need? What do I need to get?
Well, yeah. So one thing that just hit me, like quizzes. If you have quiz pools, like if you, I use a program called Respondus, so I can make my own tests and quizzes. If you can export your quiz pools, if you've created your own through Canvas, I would do that. I don't know if you're going to be able to import them into Moodle. If somebody's going to create, an API that will interface between the two styles or whatever. Pages, right? If you've got custom pages that you've created here that are aligned with curriculum, if they're custom, like this schedule, this is really the only page that I've put in here. And if it's something that you want to keep, the best way to do this, in my humble opinion, is go to the HTML editor, right? Because that's all this stuff is, and save it.
I can't see your screen.
Oh,
Yeah,
I'm sorry.
you're not sharing.
Yeah. Thank you. So give me a sec. I will. Somebody's got to keep me honest. Better?
Yeah.
Okay. So, go to the page in your pages section and go to the HTML editor and copy all the HTML and save it in a text file, save it in a folder, give it a name, give it a, I would organize things. Some would say I'm really anal about my organization skills, but I have all of my course materials for all the different courses I do. Here's my CCNA curriculum. Here's, all of the exports and everything, all of the materials that I've used and created since we went to Netacad from the original, where all you did was you enabled exams. That's the only thing their web interface was for, giving tests. So here's version 5, right? All the different courses within there, all the labs, a little anal about it. So here's 7, the 3 courses. So depending on which curriculum it is, I would probably go in, create a folder for pages, but I would put it under, these are the RNS2 pages. So I would create a folder called Netacad pages, and then I would just knock them off and save them. Because the new Moodle server, you can create custom pages, and it's similar. You can dump your HTML in there. I don't know. Right. So if I go into this test course, oops. I don't remember which account. There we go. So if I go into here, you see it's very different, the look and feel. Now they're going to apply a skin on top of this to make it look very similar to Netacad. But in general, this is Moodle. If you've never used Moodle, okay, I highly recommend this. Do this, learnmoodle.org, right? Go to learnmoodle.org, log in. I think I logged in with my Google account, if I'm not mistaken. Yep. So admin basics, this is more for people creating and managing a Moodle server. This is a Moodle test course that I created. but like this is what it looks like, right? You can create all this different kinds of content, but go through it, sign up, go through the learning course. It really does not take a ton of time. You spend an hour a day for the next week or so, or just before, whenever you have free time. And it's really going to help because you'll muddle through things and you'll be like, I don't know, I just can't figure this out. And then if you'd gone through this training, it's very helpful. It's really good. And things that you're like, yeah, I know how to do this. This is easy, easy, easy. You can fast forward. In a nutshell, when you've got a course, you go up here and you turn on editing. So now I can edit the topic and I can call this course info, right? And I can add something to this. This is more like, it's very much like Canvas where you create a section, this module, and then you add stuff into the module and there's different kinds of things here. So activities, these are all things that are going to be interactive in some way, shape, or form, or just resources, right? A book, a file, a folder, a label, a simple page. So I'm just going to put a page in here and, you get a description, and I'm going to course schedule, right? So in this you can see here is very web similar. You can expand to get more. There's the button to convert this to putting in HTML code. I paste it in, I turn code off, and bam, there's my page from Netacad. So if you have pages that you're worried about, save them, export them, get them out so you have them. Because if the course gets archived and you don't have access to it anymore, then you're not going to have access to get the HTML. Then there's general information. This is just a description. So the reality is you really want it here. And then all kinds of settings, display the page name, display the page description. I didn't put a description, so I'm not going to put it there. Display the last modified date, just in case students want to know if something's changed, because the last time I looked at it, it said last week. So let me figure out what's changed. Common module settings. Do you want to show it on the course page? Is this something you want to hide from students? Restricting access, completion information, just different tags, and you can put tags in there so that students can search for it. If you start to get some common language, is there competency information? So you can do some competency driven coursework here. Like you have to master this before you can move on to go do that. There's just so much that can be done. So there it is. It's indented. And if I put another thing in, I can just I can grab these and, move them. Come on. There you go. So it just changes the order of things. Let's see, editing this, you can move it right, you can move it left, you can hide things, you can assign roles, delete them, whatever. Lots of stuff. I mean, I could go on and on and on. This is not something I can do in an hour, right? This is going to be a workshop that we'll probably do at least 2 or 3 days, not for the full day. But quite honestly, I think if you do the self-guided Moodle course, I did it, and it's helpful, right? So if you go, let's go back to Learn Moodle, see here, they'll show us what the courses are. So I signed up for Moodle Basics, and they have you go through this process of creating a course. There's activities. You create a course and try to follow along and do things, and it's pretty helpful.
And I know you don't know, but have they kind of hinted at all when they're going to migrate
Not at all.
Yeah. I just want to. I've been in some of my way. I'm trying to figure out, can I get through this year with what I have? You
Yeah,
know?
that's the million dollar question, and that's a question that they really do need to answer, because the last thing people want to do is start a course that they're not going to be able to finish. So my guess is that if they don't announce a conversion date before the start of the school year, like say before September 1, my guess is that they will say, this is the date that any new CCNA courses will be opened
Can be
into,
created. Yeah.
and this is the date that old courses are automatically going to get archived, and they'll give you plenty of time to finish the course. That's my guess, because that's kind of the way they just did the release. They, there was some overlap. They said, okay, after this date, new courses will be created in the new one. But then you'll still have more time to complete an older course, because they're going to get a lot of pushback about that. There's no question about it.
Yeah. So I mean, the nice thing is, I mentioned yesterday, is that we're moving to Canvas. So worst case scenario, I can just export and import.
Right. You can
So,
export them from your course and import them into your instance of Canvas so that you can maintain them. Yeah. Everybody here knows how to export a whole course, or no? Is there anybody that doesn't know how to do that?
It's been a while, Mike. I don't know if you want to just show it.
Absolutely. I'm happy to. Okay. So when
Mike,
you're in,
Mike, I'm going to step away, but I wanted to say one thing about the export and import I learned is that if you export the quizzes, you got to make sure you export the banks.
oh yeah. That's why I always say export your quiz banks. And that's the way I kind of touted it earlier, because the quiz that uses a question bank is really just a list of questions from the bank. So that does you no good if you don't have the questions. Right. Absolutely.
Yeah.
So under settings in your course, oh, look, you can put it custom image. That's new. I didn't even notice that. You can export the course content. And you can also go through and change some stuff here, like, launch the speed graders, enable course grading schemes, a whole bunch of different things. I'm not going to, there's some new things that I recently learned about Canvas this past school year that I would show you, but it's kind of a moot point now. So export the course. I can export the course, or I can export quizzes. Which quizzes do I want? If all quizzes, or if you created your own, then they're there. I'm not going to export quizzes. I'm going to export the whole course, and you're going to create this export. And this is going to do its thing, and it may take, a while depending on how much material you have. But you can see here, you can leave this page because you've put the request in. It's being processed on the server, and it says it's been export, right? I just got a notification that my export is done. Oh, look, there it is. Right? But it's listed as a course name -export IMSCC. So I would put this, as you can see here, I have my 2020. I didn't create a folder for 2 CCNA 3, July 29 through August 7. Create a folder and export it into there. Now I have that content. Come on, where are you? I thought I had a link to my, oh, there it is. Yep. Go in here. There's the course. It's an IMSCC file. So, if I were to open with my archive manager on Linux, I don't know if Windows will open this. It's just a whole bunch of gobbledygook, right? But here's all of the PDF files that I've uploaded. These are probably like UUID or some kind of hash that points to folders. And if you open the folders, if you can, it doesn't seem to open them.
Now, does the quizzes, is that included, when you chose between the quiz and the course, does the course include the quizzes?
The course includes everything, I believe, but I didn't create any quizzes, so
Okay.
yeah, that's why they're not in there. But I would validate that first. As far as quizzes go, when you go to your quizzes, see, there's nothing there.
Yep.
Up here, you go to manage question banks. If you don't create question banks and you just create quizzes that have the questions in them, then you can export the quiz. But if you do like most people do and you create a question bank, right? Test bank. There. Test bank. Okay. So now if I open the test bank, I have the ability to add questions. I wouldn't go creating your own quizzes now if you haven't done it. Just
Right.
wait until the conversion. You know, or if you have them in another format, you know, use them there. You can import them from, you know, if you're working for a university and you have Blackboard, what you want to do is see if they use something called Respondus. Respondus is a question bank manager, and it interfaces with a lot of the LMSs. It runs under Windows, so I can't show it to you right this second. And it allows you to create questions. It allows you to import Word documents as long as they're forwarded properly. It creates a question bank, and then you can export it for the LMS that you use, which is really nice because I used to use Blackboard. That's what we used at Hudson Valley before they gave us Canvas, you know. So I already had them all in Respondus. So when we converted to Canvas, I just had to re-export all my quiz banks and then upload them into the LMS. So it was really a good tool. It's not terribly expensive, I don't think. So if it's something that you and or other colleagues that you know would like to use, I would explore it and look to see about getting it implemented. Now, I can show it to you. That might be something we do on Monday if you want. Just give you a quick idea of what it looks like and how it works. But I have to fire up a VM, and I don't want to waste all that time.
No, that's fine.
But Monday I can do that when we have that free day.
Sounds good.
Okie doke. Any questions? Anything else you want to see, want to hear?
Mike, general question. Could you give us a paragraph or so about what's the IoT curriculum about? Go ahead.
Internet of Things is all about all of these home automation devices, thermostats, you know what I mean, garage door openers, all the things that are connected to the internet that we use to automate tasks. And it's not limited to home. It could be, you know, machine automation in a machine shop. And it isn't specific to the like the Nest thermostats, but it's, you know, it starts to teach you about the way that these devices interact. So one of the things that I would highly suggest, once you are certified to do like CCNA1, I think you get some of the IoT classes. So this IoT Essentials, you might, or no, that's IoT Fundamentals, Introduction to IoT. This is a hard class, you know, I wouldn't start with that one. Introduction, IoT Hackathon. This is not a course that teaches you to hack. It's a course that teaches you how to set up and create a hackathon. And it's overwhelming. I opened one and I started reading it and I was like, oh my God. Like if you have somebody that has very low load, make them do this. IoT Connecting Things. This is a good first course. The Introduction to IoT is also, you know, if you have no experience with Raspberry Pi or Arduino boards, you know, I highly recommend that you get one and play with it because they're cool. It's just the bottom line, to take a little Raspberry Pi and make a computer and have it be able to do stuff for you. That's pretty damn cool. I have a Raspberry Pi that's running a web server. I know I showed this off last week, but it's actually running a web server. So I have these two little Bluetooth enabled hydrometers that I use. I put them in my buckets when I brew beer so I can monitor the alcohol content remotely. So I can hit the web server, and they're the Arduino Zeros, ARDUI, not their Arduinos, the Raspberry Pi Zero, right? I mean, we're talking about, look at this, $10, $16, on Amazon, as you just saw that. You got your HDMI output, you got a couple of USB ports, you got the ability, you got a GPIO connector, your SD card. It's just sitting over to the left, and it's, I don't know, it's like maybe 3 inches by an inch. That's how small this is. You can buy these in kits. As you can see here, this is on Amazon. So for $30, you can get a starter kit, which comes with a case and a bunch of other things, like the adapter here, a cable adapter. I'm not sure what this is for. There's other extenders, your power, your different case covers, because if you want to use the GPIO, you need this slot. Otherwise, you don't. You just have the, come on, go away. And they're just fun to play with. That's all. So I have a regular Raspberry Pi. Let's see if they have any kits here. Like the Raspberry Pi 4. This one, here's another kit, comes with a fan even. And there's so many different kits that you can get for different purposes. But there's a, where's that course? You know what? Let me go to course resources, because I'm just going to go to the course resources, down to IoT. Right, this IoT security and connecting things. So if you're going to do the connecting things, you're going to need to know what equipment you need. So, sometimes course, come on, course materials. There you go. IoT. I might even have it here, but I'm just gonna, and then open it up. Right, so they'll tell you SparkFun Raspberry Pi 3B starter kit. Of course, the 4 is out. This is an older document, so you might be able to get away with the 4. If it's bigger, better, faster, but has all the same stuff, you'll be okay. So, you open this up, you open up the SparkFun tuner kit, and there's a few extra parts you have to get, right? So here's the SparkFun version of the Raspberry Pi with some of the boards and things that you're going to need. It's $100, because they have all these extra, by the time you buy the Pi, you buy the case and these other add-ons and LEDs and all the male to male and male to female or female to female converter cables, you're going to be at the $100 anyway. Then the Tinker kit, this is an Arduino board, which is a microcontroller, a couple of servo motors, battery pack, USB cable to connect to your computer, a bunch of different resistors and LEDs and blah, 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 It's $50. So for $160, you get both of them and just have fun playing with them. They also, you know, if you're going to teach the course, that's your equipment list, $160. The kids have to have their own equipment. Or if you're a high school, you probably have to buy them for the students and then have them. I use a box, like one of those hardware boxes from Home Depot. It's a Stanley box, and it's got dividers, and it's pretty deep. It's probably about 2.5 inches deep. It's got a bunch of dividers, and I store all the parts in those, including the 2 boards and everything. So we grab the box, and at the beginning of the year, every student goes through, and we have a checklist of all the equipment that should be in there. I have spare equipment. They go in and checklist and make sure that they've got everything. And at the end of the year, it's their responsibility to make sure that that box is fully stocked the way it was, when we gave it to them.
I'm gonna have fun with that compliments of the pandemic, because my predecessor basically left everything as it was when he disappeared. So everything's in disarray in my classroom.
Yeah, sure. And there's tons of videos too, by the way. I don't know where I have them, but if you go search, there are tons of videos on activities that you can do. I just have to find them with Arduino boards and microcontrollers. Now, this microcontroller connects directly to my laptop, and I program it from my laptop, and then I send the code to the controller. And the laptop, right, if I open, right, there's an extension here. You can see I can go to Arduino Create. You can create this now on a web. So as long as you can download the extension, which interfaces between your device and the Arduino, it doesn't matter what device. So this is, Arduino on the web. I open it up and I've created an account. So, it'll, just go away. Okay. Skip. Okay. So I'm in here. I can look at my Arduino projects. If I go to the hub, I can look at different projects. Snake LED, let's look at this, how to make a matrix game. So this is maybe a video, then they tell you what you're gonna need. And eventually, you see over here, you can go right to the code. Here's the code, right? So if you wanna teach this project to your kids, you could have the code set aside, not tell them where to get the project, and you look like a hero. But it's pretty in depth. So locally, let's see if I can find my ARDUI. There's an IDE that I can run locally. And it just looks like this, right? You need 2 things. So it sets you up with this template. I can create a new one. I can upload it to my my board, or I can open, like let's say, a photoresistor. Maybe this was one of the last labs I worked on with a class, and this is the code. You can go, there's different tools that you'll get used to this, where you actually have to set up the interface between them. You can do. You have to compile the code. It looks very Java-like. You can add files. You can include libraries. Let's see if I can open. Oh, there's examples. There's a whole bunch of examples, for the different boards, right? And there's different boards. So if you've got an Explorer board, you can, look at the different examples. If I want to do display, if I want to make a bar graph or a scanning column, analog input and output, if I want to make a dimmer switch, a MIDI synthesizer to output some sounds, all kinds of things. So let's go to display. Let's look at what this one looks like. And, they give you nice code. So here it is with all kinds of comments in there so that you understand what they're doing. So it's a great way to learn. Anyway, I digress. I'm not very excited about IT, as you can tell.
Oh, that was great. Thank you.
Yeah. So, you know, if you've got a kid, if you're a high school teacher and your student is like really just flying through the curriculum and doing great, open up extra courses for them. They'll love you for it. You know, the IoT security class. Oh, where did that go? I must have, oh, that's right. I closed it. Any of the like third, fourth level classes within a group are usually, you have to be instructor certified. So you have to go through an instructor class to do the IoT security. I think the IoT connecting things might require it, but there's self-enrollment version of the class. So you can do it at your leisure. The intro to IoT, I'm pretty sure is, you know, it's open. All you got to do is go to create class and then try to create a class. You won't know if you're able to open it until you create the class and go to the bottom and look to see if your name is in the instructor list. If it's not in the instructor list, it means you have to go through an instructor class to be able to open that. Just FYI. All right. If there are no other questions, I'm going to let you guys head out of here. We are a little early, which is good. Never hurts to be done a little bit early. So have a great day. We'll see you tomorrow morning at 9 o'clock. If any of you still have more questions and you'd like to stick around and ask, I'm happy to stick around. Otherwise, I'll see you tomorrow morning.
All right, thank you.
Thank you.
All right, guys. Bye-bye.
See you tomorrow.